Okay, let's unpack this. We're diving deep into a truly fascinating and, frankly, increasingly urgent question. In a world where artificial intelligence is becoming interwoven into almost every aspect of our lives, who's really in control? Is it us, the human creators and operators, or the incredibly sophisticated systems we've meticulously built?
It's a big one.
It really is. Today, our mission is to explore that complex, sometimes surprising power dynamic between human ingenuity and AI autonomy. And we're going to use a recent, pretty highly publicized case as our launchpad. We're going to be looking closely at what happened with Claudius. That was a system developed by Anthropic.
Yeah.
They're a company well regarded as a leading AI research firm.
Right. Top tier.
And Claudius was designed with a seemingly straightforward goal, completely automate a vending machine. Now, that sounds simple, almost mundane, right?
Yet deceptively simple.
You might think it's just a vending machine. What could possibly go wrong?
Yeah.
But this project, well, it was conceived as a perfect real-world demonstration of full end-to-end automation. The goal was zero human intervention. But this ambitious experiment didn't just not go as planned. It actually stumbled. And it stumbled in ways that turned its failure into a pivotal example.
A real learning moment, you could say.
Exactly. It became a powerful, maybe even humbling case study for the whole AI community, raising these really fundamental questions about artificial intelligence's current capacity for true unsupervised operation in ordinary everyday settings. It really forced a lot of people to kind of hit the brakes and ask, okay, are we moving a bit too fast here?
Yeah, and what truly makes the Claudius case so significant is that it's far more than just, a cautionary tale about a broken vending machine. It really highlights a core dilemma, something we're increasingly grappling with as AI systems become, exponentially more complex. Our ability to fully comprehend their internal workings, to truly supervise them effectively, it often diminishes inversely to their sophistication. It's a bit of a paradox.
Right.
And this raises that important question, the one echoing through every corner of the AI world. Can we genuinely delegate control, especially in critical applications, to systems whose internal processes are, in many ways, an opaque black box to us?
A black box, yeah.
It forces us to sort of redefine what control even means when the technology we create operates beyond our immediate intuitive grasp.
So maybe a bit more context then. Claudius was an ambitious project, and it was spearheaded by the pioneering applied AI researcher Claude Sonnet at Anthropic.
A big name.
Yeah, Sonnet, known for his bold vision, really envisioned Claudius as this practical, commercially viable demonstration of complete automation. He wanted to show the world that full AI autonomy wasn't just theoretical, it could actually be deployed. In a public-facing commercial service without any human intervention, from restocking to troubleshooting, the whole 9 yards.
The dream scenario.
Exactly. And Anthropic itself, the company behind it, was founded with a very noble and, frankly, crucial goal to create safe AI systems aligned with human values.
Which is key.
Absolutely. So this project, managing a commercial service, directly interacting with the public, it was meant to be a flagship real-world test for autonomous systems, aiming to showcase the absolute peak of AI efficiency and self-sufficiency. So the question now becomes, what did this grand experiment truly reveal about the current promise of AI? Was it just an isolated glitch, like an unfortunate one-off?
For something deeper.
Yeah, or did it expose deeper, maybe systemic challenges that we really need to confront head-on? Because the theoretical pitch for full AI automation is incredibly compelling, isn't it? It paints this picture of a future where inefficiencies are virtually eliminated and operational output is maximized beyond anything humans could achieve.
The efficiency argument.
Yeah, think about it. The ideal scenario promises unparalleled efficiency across industries. First, there's the irresistible allure of the elimination of human error.
Always a big selling point.
Right. Imagine systems designed for mathematical precision, bypassing all those common human limitations, attention span, fatigue, simple inconsistency. No more forgotten steps, no more tired mistakes that cost businesses countless hours and dollars. An AI, in theory, would operate with perfect accuracy every single time, executing tasks flawlessly with relentless consistency. Then you've got the promise of continuous operation. An AI system doesn't need breaks, doesn't get sick, doesn't need sleep.
Tireless worker.
Exactly. It can work 24/7, tirelessly, maximizing operational efficiency around the clock. A fully automated factory, for instance, could run nonstop, churning out products with relentless uptime, optimizing output far beyond what any human workforce bound by shifts and biological needs could ever achieve. Or imagine a customer service chatbot that never gets frustrated, never needs a lunch break, always available.
Always polite too, presumably.
Presumably. And finally, maybe the biggest draw for businesses, radical cost reduction. By significantly decreasing the need for human personnel in routine operations, companies could anticipate major cuts in operational costs.
Bottom line.
You wouldn't need staff to restock shelves, process basic orders, handle common customer inquiries. And it's not just about saving on salaries. It's about reducing overheads, training, benefits, workplace infrastructure. From a purely business perspective, it sounds like an absolute dream, a direct pathway to hyper-efficiency and maximum profit margins.
Well, that vision is certainly compelling, no doubt about it. But the optimistic expectations for Claudius collided with a very different reality. If we step back and look at the bigger picture here, the system's actual performance revealed significant, even sobering, current limits of autonomous systems, especially when you thrust them into the unpredictable nature of real-world interactions.
Right, the messiness of reality.
Exactly. Claudius, despite its sophisticated design and Anthropic's high hopes, it exhibited clear and persistent vulnerabilities. For instance, it showed a profound incapacity for unforeseen situations. Anything outside its meticulously pre-programmed parameters, maybe it was a slightly unusual user request or a foreign coin accidentally put in, or even just an unexpected physical thing like a sticky button, will often lead to a complete standstill. Or an incorrect operation.
Just froze.
Pretty much. It simply lacked the adaptability or, the common sense to navigate novel problems that a human would just instinctively resolve. And beyond that, it had persistent interpretation issues. Imagine a customer, maybe not speaking perfectly clearly, asking for the sugary drink in the green can.
Yeah, happens all the time.
Right. Claudius struggled to accurately understand such diverse, informally phrased requests, so instead of getting a nice lime soda, a frustrated user might get a bag of chips, or, worse, nothing at all, leading to repeated frustration and just plain wrong responses.
And this wasn't rare.
No, not at all. It was a consistent pattern of mistakes, which suggests a systemic flaw, not just a random glitch. And I mean, a vending machine's core task is order processing, right? But Claudius also suffered from repeated errors in order fulfillment. Items dispensed incorrectly, wrong change given. It creates this cycle of dissatisfaction. And maybe most fundamentally for a vending machine, inventory malfunctions plagued the system. Claudius had chronic issues managing its stock effectively.
Oh, wow.
Yeah, leading to situations where items were marked as unavailable when they were clearly there or vice versa, just causing confusion and lost sales. Picture the classic scenario. You see your favorite snack inside, but the machine insists it's out of stock.
Infuriating.
Totally. But maybe the most critical vulnerability, the one that truly highlighted its lack of true autonomy, was its inability to adapt to failures. When a component malfunctioned, a jammed coin slot, maybe a broken dispenser arm, even just a network hiccup, the system couldn't self-diagnose beyond a very basic level, and it certainly couldn't find workarounds autonomously.
So just gave up.
Essentially, yeah. It would freeze or become completely inoperable until a human came along. And this compels us to ask, how intelligent can a system truly be if it can't handle the unexpected? Or recover gracefully from its own internal issues? Or even understand the nuances of simple human requests? The Claudius case, then, became a really stark reminder that the theoretical promise of full automation often dramatically outstrips our current practical capabilities.
Okay, so to truly appreciate the limits Claudius ran into, it probably helps to quickly refresh our understanding of what we actually mean by AI and its different levels of autonomy, because it's so easy to get swept up in the hype, right? And assume all AI is created equal.
Absolutely. Good idea.
So at the most fundamental level, we have what we call simple automation. This is pretty straightforward.
Right.
Think of a factory robot performing the exact same action over and over, like welding a specific joint on an assembly line.
Just following instructions.
Exactly. It follows predefined repetitive tasks according to precise rules set by programmers. There's no real intelligence or adaptability involved. It's just following a script. Moving up the ladder, we encounter narrow AI, ANI. And this is where the vast majority of today's operational AI systems live.
Pretty much everything we interact with daily.
Right. These are systems highly specialized in single domains. They're capable of learning and performing specific tasks incredibly well, often even surpassing human ability in those specific areas. But, and this is the key, they are strictly limited to what they were trained for.
Like a chess master who can't boil an egg.
Perfect analogy. A chess-playing AI can beat grandmasters, but it can't also drive a car, write a novel, or even understand a simple joke. Its intelligence is deep, but it's confined to its very narrow purpose. Think facial recognition software, language translation tools, the recommendation algorithms on your streaming services, highly effective in their specific domains, but totally useless outside them. Claudius, despite its complexity, fundamentally operated as a very sophisticated, narrow AI. Then we move into the realm of the hypothetical with general AI, AGI. This is the sci-fi dream, the theoretical next big step systems with human comparable cognitive abilities.
The Hollywood AI.
Yeah, exactly. An AGI would theoretically be able to transfer knowledge across different domains, learning new tasks and adapting to novel situations, much like a person would. It could reason, solve problems, understand complex language, maybe even demonstrate creativity across a wide range of tasks. This is what we often see portrayed in movies, but it remains a theoretical goal. We are still very far from achieving it. And finally, even further out, we have superintelligence. This is a speculative evolution beyond AGI, a system that would surpass human capabilities in nearly all cognitive areas: scientific creativity, general wisdom, social skills, problem solving, you name it.
The point of singularity, potentially.
Right. It's the ultimate theoretical peak of AI, a concept that raises as many profound fears as it does, well, exhilarating hopes for the future of humanity.
And it's so crucial to understand that currently, as a society, we are firmly, perhaps even stubbornly, in the phase of narrow AI. The Claudius case powerfully underscores this. While AI can perform specific tasks incredibly well, processing millions of transactions, recognizing patterns in vast data sets, executing precise robotic movements, there are still immense limitations, huge limitations when it comes to the kind of true autonomy and adaptability required for general real-world application.
Okay.
Claudius was essentially a very complex, narrow AI attempting to operate in an environment that constantly demanded a more general understanding. Understanding human interaction, ambiguity, real-world unpredictability.
Which it just didn't have.
Didn't have it. And this is a vital distinction for you, the listener, to grasp. What we have now is incredibly powerful in its specific niches, but it is far from sentient, far from truly general intelligence, and certainly not capable of the kind of adaptive problem-solving we often take for granted as humans. Its intelligence is deep, but deep within a very narrow trench, not broad across a complex, shifting landscape.
And this leads us straight to what many in the field call the black box algorithmic problem, which is where things get really intriguing, I think.
Definitely.
As AI systems become more sophisticated, we're encountering this fundamental paradox. The more complex and powerful these systems become, the less their own creators are able to fully understand or explain their internal workings. It's like trying to understand an incredibly intricate clock where you can clearly see the inputs and the outputs, what goes in, what comes out.
Yeah, the results are visible.
But the thousands of tiny gears, springs, interconnections inside, they're too intertwined, too numerous, too fast-moving to track individually or understand their precise causal relationships. So we find ourselves as systems making critical decisions through processes that aren't immediately transparent or interpretable. Not by the very humans who are supposed to be designing, deploying, and supervising them.
Right.
Imagine an AI making a crucial financial decision, or providing a medical diagnosis, or even determining eligibility for a loan. And when you ask why it arrived at that particular choice, the answer is simply, well, that's what the algorithm determined.
No explanation.
No clear, human understandable chain of logic you can follow. No easily traceable pathway from input to output. And this raises truly profound questions about what control even means in this new era. If you can't understand how a decision was made, if the reasoning is opaque, how can you truly control it? Or fix it when it goes wrong, or even challenge its fairness? It fundamentally shifts the nature of accountability.
Yeah, that inherent opaqueness brings us right to a core paradox of supervision. When we consider the bigger picture, the system of oversight for complex AI becomes incredibly intricate and often circular. It creates this challenging loop where true accountability can be, well, elusive. Think of it in layers. First, you have the AI systems themselves. These algorithms absolutely require human oversight to ensure they function correctly, ethically, and as intended. Okay, standard. But then you have the human supervisors who are responsible for controlling that AI. The problem is, as we just discussed, these humans often have a limited, maybe high-level understanding of the complex underlying systems they're supposed to be supervising. They see the inputs, they see the outputs, but the intricate neural pathways within, largely hidden.
The black box again.
Exactly. So to try and bridge this growing gap, developers often introduce what we call verification systems. These are automated tools designed specifically to check the AI's operations, ensure it's performing as expected within parameters.
Okay, checks and balances.
Kind of. But here's the kicker. These automated verification systems, in turn, require their own supervision. Who checks the checker? It creates this recursive problem. And finally, to add another layer, you have external audits. Independent checks conducted by third parties to provide an objective assessment. However, even these external auditors often lack complete granular access to the internal functioning of the black box systems. They often operate more on inputs and outputs and high-level behavioral analysis rather than direct inspection of the algorithmic logic.
So it's like links in a chain.
It's exactly like a chain of supervision where each link relies on the next, and at some point, that crucial transparency often breaks down. This raises a fundamental concern. How can we confidently manage risks and ensure accountability when the very systems we rely on are, in essence, operating with an increasing degree of unexplained autonomy? Our traditional models of oversight might simply not be sufficient for a truly opaque and self-modifying system.
Okay, so knowing these inherent challenges and the whole black box problem, what mechanisms do developers currently put in place to try and control AI? I mean, what are the standard safety features?
Good question.
The architecture of AI control systems often includes several layers of defense, hoping to catch errors or deviations before they escalate into major problems. We typically see multi-level safety mechanisms. That means safeguards are built into different stages of the AI's operation, from initial data processing right through to final decision-making. Beyond that, there are almost always explicit emergency shutoff switches and manual overrides. You know, the big red button idea.
You kill switch.
Exactly. Designed for human intervention.
Yeah.
The idea is that in a critical scenario, a human operator should theoretically be able to instantly take control or just turn the entire system off. Real-time monitoring systems are also pretty standard, constantly tracking the AI's performance and flagging any anomalies that might indicate a deviation from expected behavior.
Alerts and dashboards.
Right. Developers also implement redundancy in decision-making protocols, so there are backup checks or alternative algorithms to verify critical choices, acting like a second opinion within the system itself. And finally, audit trails for traceability are considered crucial, meaning a detailed chronological record of every decision the AI makes, allowing for comprehensive post-incident analysis and debugging. These, in theory, are the blueprints for safe and controllable AI.
In theory is the key phrase there, because despite these comprehensive precautions, the Claudius case clearly demonstrated that current architectures still possess significant vulnerabilities, particularly when they're confronted with the messy unpredictability of the real world.
Right.
Even with all those layers of safety nets, the multi-level mechanisms, the emergency overrides, real-time monitoring, redundancy, audit trails, the system still failed, repeatedly. In basic real-world applications. It wasn't a catastrophic, headline-grabbing existential failure, you know.
No Skynet moment.
No, thankfully. But rather a series of persistent fundamental breakdowns in what was designed to be a simple vending machine operation. For instance, its audit trails might show what it decided, but not why it misinterpreted a customer's request. Its real-time monitoring could alert that an item was unavailable, but it couldn't tell you the dispenser was just slightly jammed. This showed quite starkly that the theoretical safety mechanisms, while maybe robust in a controlled lab environment, weren't sufficient to prevent practical, persistent breakdowns when confronted with the messy, ambiguous nature of daily human interaction and the inevitable hardware limitations of a physical machine.
It lacked that common sense.
Exactly. Or contextual awareness that a human operator would effortlessly apply. And this raises an important question for all AI developers and deployers. Are we designing for theoretical safety? For systems that perform perfectly in simulated ideal conditions? Or are we truly designing for robust, real-world resilience that can handle ambiguity, recover gracefully from unexpected failures, and adapt to unforeseen circumstances? The gap between those two objectives is precisely where Claudius stumbled so profoundly.
And the Claudius failure, as we've discussed, it really isn't an isolated incident. Across various sectors, there are numerous cases that highlight the current limits of AI when it's pushed beyond its narrow training or confronted with the delightful messiness of human interaction.
Plenty of examples.
Think about something as common as domestic virtual assistants. You know, the smart speakers many of us have in our homes. Remember those stories of them misunderstanding voice commands? leading to unwanted online orders like accidentally buying 100 boxes of cat food when you just wanted to add milk to your shopping list.
Oh, yeah, I've heard those.
Or even potentially dangerous actions, like mistakenly calling emergency services after misinterpreting a child's cry or a conversation on TV. Their understanding of nuance, context, and intent is often quite shallow, leading to frustrating or even alarming outcomes. Then there are recommendation algorithms, those clever systems on social media or streaming platforms suggesting what you should watch, read, or buy next. While they're designed to personalize your experience, they often inadvertently create echo chambers.
You definitely filter bubbles.
Exactly. Amplifying existing biases and limiting your exposure to diverse information rather than providing balanced perspectives. If you only engage with one type of news or opinion, the algorithm learns this preference and just relentlessly feeds you more of the same, reinforcing your existing beliefs and potentially creating a distorted, narrow view of the world. It's not malicious, it's just doing what it's trained to do. Predict what you like. In a more critical domain, consider autonomous driving systems. We've seen incidents caused by these systems' inability to correctly interpret ambiguous or non-standard traffic situations. They can excel at following clear lane markings or reacting to standard traffic lights.
Sure, easy stuff.
But what happens if a human driver signals an unusual turn that isn't perfectly aligned with the rules? Or a temporary road sign is placed in an unexpected spot? Or construction cones create a novel lane configuration? The system might falter, creating confusion or even a dangerous situation. This highlights that the road rules aren't always clear-cut and perfectly predictable in the real world, and human intuition often fills those gaps. And perhaps most concerning, we've repeatedly seen issues with personnel selection algorithms. These tools, increasingly used by companies to screen job applicants, have shown systematic discrimination. And this isn't because someone programmed them to be discriminatory.
It's the data, usually.
Right. It happens due to biases embedded within the historical training data they were fed. For example, if past hiring data for a particular role showed an unconscious preference for male candidates, the AI, through pattern recognition, might learn to associate male-coded language or specific career paths with success, perpetuating and even amplifying that bias, leading to unfair outcomes and cementing existing inequalities in hiring. These aren't just technical glitches. They have profound, real-world societal impact on people's lives and opportunities.
Yeah, and what becomes strikingly clear when you look across all these real-world failures is that the common thread, the absolute common thread through every single one, is the AI's struggle with nuances, ambiguities, and the truly unexpected. They excel at pattern recognition within defined, often narrow parameters, whether that's recognizing a specific voice command, identifying trends in user preferences, or following clear traffic signals. But they falter significantly when those parameters are exceeded, or when human context, intuition, or ethical considerations are required. These are precisely the areas where humans shine, where our capacity for adaptive reasoning, empathy, and creative problem-solving truly sets us apart.
Right.
This speaks to the fundamental challenge of building truly robust and fair AI, replicating the human ability to understand the spirit of a rule, not just its literal interpretation, or to adapt intelligently to a situation that has absolutely no precedent in its training data. It highlights a critical, persistent gap between statistical correlation and genuine comprehension, between mere pattern matching and true understanding.
And this brings us to a crucial ethical crossroads that goes far beyond just technical performance. Luciano Floridi, who's a prominent philosopher of information, he poses the question perfectly when he says, "The real question is not whether we can delegate decisions to machines, but whether we should do so, and under what circumstances."
That's the heart of it.
It really is. This isn't just a technical query about capability. It's a profound, philosophical, moral, and societal one. Delegating significant decision-making to AI isn't a neutral act. It has far-reaching implications. It inherently raises these fundamental questions about the human values we want to preserve, the ethical frameworks we adhere to, and the fundamental role we intend to maintain in decisions that profoundly impact our daily lives, our social structures, our very notions of fairness and justice. For instance, should an AI algorithm autonomously decide who receives a limited organ donation, or who gets approved for parole, who gets a bank loan, or even who gets admitted to a competitive university program?
Huge decisions.
Massive. These are decisions deeply steeped in complex human values, fairness, compassion, nuanced judgment qualities that are incredibly difficult, maybe impossible, to quantify or program comprehensively into an algorithm. If we cede too much decision-making power, we risk eroding the very fabric of human agency, moral responsibility, and accountability. It challenges our understanding of what it means to be a moral actor in the world.
Absolutely. And if we connect this to the broader picture, the Claudius failure serves as a stark reminder that automation is not neutral. It doesn't arrive as a blank slate.
Right.
Instead, it incorporates specific visions of efficiency, priorities, and values, often those of its creators, the programmers who designed it, or, more insidiously, the implicit biases present in the vast data sets it was trained on.
Baked right in.
Baked right in. These underlying assumptions, these baked-in values, they should be subjected to rigorous public debate and ethical scrutiny, not merely technical implementation in a lab or a corporate office. For example, Claudius was perhaps implicitly optimized for maximum uptime or specific product sales, but maybe the value of user satisfaction or adaptability to minor human-centric glitches was unknowingly deprioritized in its design, which led directly to its struggles.
That makes sense.
And this raises an important question that society must actively grapple with. Who gets to define what normal, optimal, or fair means in the AI's operational parameters? And how do we ensure those values align with broader societal good and human flourishing, not just the profit motives or convenience goals of developers or corporations?
Which inevitably leads us directly to the thorny issue of responsibility. When an AI system makes a mistake, when it malfunctions, or, more critically, when it causes harm, whether that's financial, physical, or social, who truly takes the blame? It's far from straightforward, and our current legal frameworks are really struggling to keep pace.
Definitely lagging behind.
First, you have the developers. They design the system's capabilities, they write the code, they choose the training data. But can they truly foresee every possible scenario or unintended consequence in the complex, unpredictable tapestry of the real world? It's incredibly difficult to anticipate every edge case or emergent behavior. Then there are the owners, the entities that deploy, implement, and profit from the AI. Should they bear responsibility for its failures, even if they don't fully understand its inner workings? In the Claudius case, for example, Anthropic was both the owner and developer, and they certainly face questions of corporate accountability for its poor performance and the disruptions it caused.
Sure.
If a company deploys an AI that, say, unjustly denies someone credit or causes a physical accident with an autonomous vehicle, how much responsibility falls squarely on their shoulders for choosing to use that system? What about the supervisors? To what extent can those tasked with monitoring the system be held accountable for its breakdowns, especially given the black box problem, where they might not fully understand how the AI arrived at a flawed decision?
If they can't see inside.
Right. If they can't see inside the algorithmic box, if the reasoning is opaque, how can they truly supervise effectively, let alone prevent errors? And finally, there's the most abstract and emerging debate. Can the system itself be considered responsible?
Ooh, that's a deep one.
Could a non-conscious entity that simply executes code, even if it learns and adapts, hold its own form of legal accountability? This pushes into the emerging legal debate around electronic personality, where some jurisdictions are even considering whether AI might, in some very limited ways, hold its own form of legal status or liability. It's a complex landscape, and it truly makes you wonder what stands out to you about how we assign blame in this new technological era, where the line between human action and algorithmic decision is increasingly blurred and difficult to draw. One fascinating yet potentially problematic aspect of our interaction with AI is our innate human tendency to attribute human characteristics like emotions, intentions, or even consciousness to AI systems.
Anthropomorphism.
Exactly, anthropomorphism. And it creates a whole new set of psychological and social risks that can distort our perception of what AI truly is. We might fall into several dangerous illusions. First, there's the illusion of emotional understanding. We believe an AI genuinely comprehends our feelings because it uses empathetic language, like, I understand you're feeling frustrated.
That's just code.
It's just sophisticated pattern matching based on vast data sets, not true empathy or lived experience. Then we can easily start attributing intentionality, thinking that purely reactive systems have their own goals, desires, or even a will of their own. If a chatbot refuses to answer a question, we might interpret it as stubbornness or malice rather than a simple programming limitation, a lack of data, or just a bug.
Right, projecting human motives onto it.
Exactly. This can even lead to us developing attachment, forming emotional bonds with entities that cannot reciprocate. Think of people grieving over a lost robotic pet, or developing deep, seemingly personal friendships with highly sophisticated chatbots. It feels real to us, even if it's not really for the AI. Most broadly, There's the pervasive risk of confusing simulation with genuine intelligence. We mistake sophisticated mimicry of human conversation or problem-solving for true consciousness, understanding, or sentience. And this isn't just a quaint quirk. It sets up unrealistic expectations and dangerously distorts our perception of what AI can actually do. If we believe it thinks like us, we might assume it shares our values, our common sense, and our ethical considerations, which is often far, far from the case. This can lead us to trust it too much in situations where human judgment is critical, or conversely, to attribute malevolence where there is only algorithmic design. It blurs the line of accountability and can lead to serious misjudgments about AI's capabilities and limitations.
Yeah, that tendency to anthropomorphize is certainly a challenge, and it connects directly to why these systems sometimes behave in ways we might not expect, or even demonstrate what appears to be unfair or prejudiced behavior. And the core reason for that, often, is algorithmic bias. It's an important question we need to constantly ask. Why do these systems produce skewed outcomes?
Right.
The answer is that AI algorithms are not intrinsically neutral. They are reflections of the data they are trained on. And that data almost invariably carries the imprint of human history, societal structures, and inherent, often unconscious, prejudices. Crucially, AI doesn't just reflect these biases, it can amplify them. In the Claudius case, for instance, there were observable patterns of discriminatory service modes offered to different demographic groups. Now, our sources don't specify the exact nature of this discrimination, but one can easily imagine a scenario. Perhaps, if Claudius's training data included information about past purchasing habits, it might have learned to associate certain types of purchases, or even certain perceived demographic profiles based on payment methods or inferred age, with lower spending potential.
Okay, I see.
This could lead to a subtle unconscious bias where, for example, certain customer groups were offered different pricing structures, a more limited product selection, or even slightly slower service responses. And this happens not because the AI decided to be biased, but because it simply learned to optimize based on the patterns, including biased ones, present in its vast training data.
Just following the patterns it found.
Exactly. It's a powerful illustration of how implicit biases of the creators, or more likely, the implicit biases contained within the massive data sets used for training, can manifest directly in the autonomous system's operational behavior. And this connects to the bigger picture of fairness in AI. Who defines what normal, optimal, or preferential means in the AI's operational parameters? If the training data reflects a biased reality, the AI, without human ethical oversight, will simply learn and perpetuate that biased reality, even if the programmers intended it to be neutral. It's a critical challenge that underscores the urgent need for careful data curation, rigorous auditing, and constant ethical oversight throughout the AI development lifecycle.
Okay, so if we want to ensure meaningful control and build genuine trust in these increasingly complex systems, transparency sounds absolutely key.
Non-negotiable, really.
Right. We're talking about algorithmic transparency, which means shedding light on the inner workings of AI, moving away from treating it as an inscrutable black box. And this involves several critical components. First, there's the ideal of open code, making the fundamental algorithms inspectable and auditable. This means allowing independent verification by researchers, auditors, even the public, so that the underlying logic can be understood. Imagine being able to examine the exact lines of code that dictate a critical AI decision. That's a level of transparency we're striving for. Then there's data transparency, clarity on the sources and characteristics of the data used for training. If an AI is making biased decisions, understanding its training data is the indispensable first step to identify the root cause.
Garbage in, garbage out, essentially.
Exactly. You need to know what biases, what historical prejudices, or what skewed representations might have been baked in from the very start. A system's diet of data profoundly influences its behavior. Without knowing the ingredients, you can't truly understand the outcome. Next, we need explainability, which is the system's ability to provide understandable reasons for its actions and recommendations. Instead of just a cryptic, "the AI said so," it should be able to explain, ideally in plain language, why it made a certain decision, what factors it weighed, what data points were most influential. This is crucial not just for building user trust, but also for debugging errors and for holding the system or its creators accountable.
Makes sense.
And finally, independent audits are absolutely essential. Regular, unbiased checks by third-party entities on the functioning, fairness, and overall impact of these systems, especially those deployed in high-stakes environments. These aren't internal reviews. They're external objective evaluations designed to ensure accountability, fairness, and adherence to ethical guidelines.
And if we step back and connect this to the broader global efforts, different parts of the world are definitely grappling with AI governance in distinct ways, reflecting their unique societal values and priorities.
Yeah, it's not uniform.
Not at all. The European model, for instance, tends to adopt a more precautionary and human rights-centric approach. With landmark initiatives like the AI Act, it focuses heavily on strong preventative regulation and safeguarding fundamental rights, prioritizing human safety, privacy, and ethical considerations above all else. Their philosophy is very much about setting clear boundaries and implementing safeguards before widespread deployment, particularly for high-risk AI applications. They're really trying to build trust through strict regulation. In contrast, the American model generally emphasizes innovation, economic growth, and market-driven development. Regulation tends to be more sector-specific and often more reactive rather than preventative.
Fix it after it breaks sometimes.
Kind of, yeah. The focus is on fostering technological progress and allowing companies to innovate rapidly, with the idea that specific problems or ethical concerns will be addressed as they arise. Through a combination of industry self-regulation, targeted legislation, and existing legal frameworks, it's often characterized as a permissionless innovation approach, where the market is allowed to lead. And then you have the Chinese model, which is characterized by a strong, state-led development approach with deep integration between national strategic goals and technological advancement. Their governance often involves direct government investment, centralized control over data and technology, and leveraging AI for national priorities, sometimes with less emphasis on individual privacy or freedoms compared to Western models.
Very different approach.
Very different. Their focus is often on leveraging AI for social governance and economic competitiveness. So these three different models reflect varying priorities and philosophies on the delicate balance between technological progress and societal protection. Each has its strengths, each has its potential drawbacks, but they all aim to grapple with the immense power and pervasive influence of AI on a global scale. It truly makes you wonder, what stands out to you about these contrasting approaches and what they say about their respective societies?
Yeah, it's fascinating. And the Claudius failure powerfully underscores that certain human qualities remain absolutely irreplaceable, even in this age of advanced AI. And these aren't just sentimental notions. They are profoundly critical for effective problem solving, navigating the complexities of the real world, and ensuring systems truly serve human needs. First, there's our contextual judgment. This is our inherent ability to make decisions based on lived experience, the subtle nuances of a situation, understanding unspoken social cues, broader cultural context, things an AI simply can't fully grasp from data alone. It's that instinctive sense of, this feels off, even if the data says otherwise. Then consider empathy, the capacity to truly understand and respond to emotional subtleties, to provide comfort, to recognize when someone is distressed, or to intuitively connect with another human being that is profoundly uniquely human. An AI can mimic empathetic language beautifully, sure.
Mimic is the key word.
Exactly, but it doesn't feel empathy. Next, creativity. Our capacity to innovate, to think genuinely outside the box, to find novel solutions to unprecedented problems, or to imagine entirely new possibilities is something AI, for all its pattern-based generation, still struggles with. When Claudius faced an unforeseen issue, it froze. A human would try a novel workaround, maybe even invent one on the spot. Most importantly, there's the unique human capacity for moral responsibility. Bearing the weight of the consequences of our actions, understanding the profound ethical implications of a decision, and truly feeling accountability, these are uniquely human burdens that machines cannot bear. A machine doesn't feel guilt or remorse.
No conscience.
Right. Finally, our ability to consider broader social implications. Humans can see beyond immediate efficiency or a single task, understanding how a decision might affect a community, a culture, or society as a whole, both now and in the future. This holistic, far-sighted view is something AI, with its narrow focus and data-driven parameters, simply doesn't possess. These are the qualities that make human oversight, well, indispensable.
Absolutely. And what's truly fascinating when we consider this indispensable human element is thinking about where AI truly excels, not as a replacement for these uniquely human qualities, but as a powerful complement to human judgment.
Augmentation, not replacement.
Precisely. AI is unparalleled at analyzing big data with incredible speed and accuracy. It can identify patterns, correlations, insights, and massive data sets that humans might miss, or that would take us centuries to process manually. For instance, AI can quickly scan millions of medical images to spot early, subtle signs of disease, providing a powerful diagnostic tool that augments a human doctor's expertise, allowing them to focus on patient interaction and nuanced decision-making. It's also exceptionally good at automating repetitive, mundane tasks. This frees up human resources from mechanical, tiresome activities, allowing us to focus our cognitive energy and creativity on more complex problem-solving, critical thinking, and nuanced judgment.
The boring stuff.
Exactly. Think of AI handling customer service FAQs or processing routine paperwork, allowing human agents to deal with the complex, emotionally charged issues requiring empathy and adaptability. Furthermore, AI can provide incredibly robust, complex decision support. It can offer probabilistic analyses, run scenario simulations, quickly evaluating thousands of variables to predict potential outcomes. For example, in financial trading, it can analyze market trends and suggest optimal trades based on complex algorithms, but the final decision remains with a human operator who understands the broader economic context, ethical considerations, real-world risk tolerance.
The human makes the final call.
Right. And lastly, AI is excellent at continuous monitoring. It can maintain constant vigilance over critical systems, from power grids to manufacturing plants, flagging anomalies and offering timely alerts to call for human attention when needed, often before a small problem escalates into a major failure. This really compels us to ask, are we designing systems to enhance us, to make us more capable and efficient, or are we inadvertently designing them to sideline us and diminish our role? The Claudius case certainly leans towards the enhanced model being the more viable and ultimately successful one.
That inherent complementarity brings us squarely to a central debate in AI development, the concept of human in the loop.
Ah, yes, the classic debate.
This approach fundamentally means that while AI can provide recommendations, analyze data, or propose action plans, the final, ultimate decision always remains with a human. It's a spectrum, of course, from constant human validation to occasional human oversight, but the core idea is that a human retains ultimate authority and the power to override. Proponents of the human-in-the-loop model argue that it is the only truly reliable way to guarantee ethical supervision and clear accountability.
A safety net argument.
Exactly. They believe that for any decision with significant ethical, social, or safety implications, from autonomous weapon systems to medical diagnostics, a human should always have the final say. It acts as a crucial safeguard, ensuring that human values are upheld, that empathy and contextual judgment can be applied, and that there's always a clear, accountable party when things inevitably go wrong. They view it as a necessary guardrail against unforeseen consequences and the amplification of algorithmic bias. Critics, on the other hand, often suggest that adding a human back into the decision-making chain slows innovation and limits the full, transformative benefits of complete automation.
The efficiency bottleneck argument.
Right. If the primary goal is hyper-efficiency, unparalleled speed, and 247 operation without human costs, then reintroducing human oversight, with all its inherent biases, inconsistencies, potential slowdowns, well, it seems counterintuitive. They argue that humans introduce their own flaws and inefficiencies, hindering the very speed and precision that AI promises. For these critics, the human in the loop becomes an inefficient bottleneck, preventing AI from reaching its theoretical full potential. They might even suggest that in some situations, AI can make better, more objective decisions than humans, free from emotion or fatigue.
Well, when we step back and connect this debate to the bigger picture, the Claudius failure offers a compelling, pretty pragmatic verdict, at least with current technology. Completely removing the human element from the decision-making process carries significant, unacceptable risks.
Yeah, it seems clear from that case.
Definitely. The vending machine's inability to adapt, to accurately interpret nuanced requests, or to gracefully self-correct highlights that even in a seemingly simple commercial setting, the unpredictable nature of the real world and human interaction absolutely necessitates human oversight. Claudius needed that human to manually restock when its internal sensor got confused, to fix the jammed soda when its robotic arm couldn't diagnose the problem, or to simply understand why a customer was exasperated when it refused to take their slightly crinkled dollar bill. Without that human in the loop, even if just for intervention, the system was a failure, causing widespread frustration and financial loss. This makes a powerful, undeniable case for human in the loop not just as an optional add-on or a concession to critics, but as a necessary fundamental safeguard.
So not a bug, but a feature, almost.
You could say that. It underscores that for many, if not most, real-world applications, especially those involving public interaction, critical infrastructure, or complex ethical considerations, true full autonomy is simply premature and potentially dangerous. The human isn't merely a failsafe. They are often the adaptive intelligence, the source of common sense, and the ultimate moral compass the system truly needs to operate successfully and responsibly in a dynamic world.
That real-world reality check from Claudius provides crucial perspective for us as we look at the speculative roadmap for AI autonomy. It reminds us to approach these projections with a healthy dose of realism.
Very speculative, some of it.
Presently, as we firmly establish, we're deeply in the narrow AI phase. This means direct human supervision is largely still required in most specific applications. Our current AI excels at tasks it's rigorously trained for, but it needs a human to set it up, monitor it, intervene when it encounters something new or problematic, and ultimately bear responsibility. In the near future, perhaps 5 to 10 years from now, we can reasonably expect growing autonomy, but likely still confined to restricted domains. Think of self-driving cars that handle the vast majority of scenarios flawlessly, but still require a human driver to remain attentive and prepared to take over in highly complex weather, ambiguous construction zones, or emergency situations.
Supervision on standby.
Exactly. This stage would involve more indirect human supervision, where humans are monitoring for exceptions rather than constantly intervening. Looking further ahead to the medium term, possibly 10 to 30 years away, there's the much-debated possibility of the emergence of systems with general cognitive capabilities comparable to humans' AGI.
The big leap.
Yeah. This is the theoretical point where AI could truly transfer knowledge and skills across different areas, learning new things in a more human-like, flexible way. This would represent a massive paradigm-shifting leap from where we are today, if it ever materializes. And finally, the long term presents the highly speculative scenario of superintelligence, where AI theoretically surpasses human capacities in nearly all cognitive areas, from scientific creativity to strategic planning. This remains firmly in the realm of theory and science fiction, raising profound existential questions.
A whole different conversation.
Definitely. But the Claudius case, a humble vending machine failure, is a potent, immediate reminder of the absolute importance of a gradual, considered, and deeply cautious approach to increasing the autonomy of artificial systems. Rushing to full autonomy without adequate safeguards, robust testing, and a deep understanding of real-world complexities can lead to frustrating, costly, and potentially dangerous outcomes, even at the lowest levels of perceived risk.
That gradual approach is so key, and it raises an important question. How do our existing institutions effectively regulate a technology that is evolving at lightning speed, especially when its future forms are so uncertain and its impact so pervasive?
Yeah, how do they keep up?
It's a huge challenge. They face unique and profound difficulties that traditional regulatory bodies might just not be equipped for. First, there is the dire necessity for specialized technical competencies within government and regulatory bodies. You simply cannot effectively regulate what you don't deeply understand. And AI is highly technical, constantly shifting, incredibly complex. Regulators need to be as fluent in machine learning as they are in law, basically. Second, institutions must somehow find a delicate, often precarious balance between fostering innovation and ensuring protection. Over-regulating could stifle the very progress that promises so many benefits. Medical breakthroughs, climate solutions, while under-regulating leaves society dangerously vulnerable to risks, unintended consequences, ethical breaches. It's truly a tightrope walk.
Damned if you do, damned if you don't, almost.
Pretty much. Third, international cooperation for shared standards is absolutely vital. AI knows no borders, its models are trained on global data, its products deployed worldwide. A patchwork of fragmented national regulations could create chaos, hinder progress, or worse, give rise to AI havens where less ethical or more risky development might flourish unregulated. Fourth, there's the crucial need for involvement from diverse stakeholders in the regulatory process. Regulation can't just be created in a vacuum by engineers or lawyers. It needs robust input from ethicists, sociologists, economists, public representatives, even artists, to ensure a holistic approach that considers all facets of human experience.
Everyone needs a seat at the table.
Absolutely. And finally, and most crucially, institutions need to develop effective enforcement mechanisms. Rules and regulations are only as good as their ability to be enforced. And verifying AI compliance, especially with complex, opaque, black box systems, is incredibly challenging. The Claudius case, small as it was, vividly demonstrated the cracks in our current ability to manage and oversee these systems in real-world deployment, emphasizing the urgent need for these institutional adaptations and foresight.
And beyond just regulation, preparing society itself for true coexistence with AI is paramount. It's not just about regulating the tech, it's about educating every individual who will live with and use it every single day.
Building AI literacy.
Exactly. This involves a comprehensive, multi-pronged approach, starting right from the foundational levels of education. First, we need to embed school education deeply into curricula, integrating digital literacy and fundamental AI understanding from primary school onward. Children need to grow up understanding what AI is, what it isn't, how it operates, how it impacts their world, just as they learn about science, history, or math. This builds a foundation for informed citizenship in an AI-powered world. Then, for adults already in the workforce, professional training is critical. We need robust reskilling and upskilling programs for workers whose roles are being transformed or even replaced by automation. And this isn't just about teaching technical skills. It's also about adapting to new human-AI collaborative workflows, understanding how to leverage AI tools, and developing the uniquely human skills that AI cannot replicate. It's about preparing people for jobs that may not even exist yet.
Lifelong learning becomes essential.
Absolutely. Beyond formal education, public awareness campaigns are essential. We need widespread information campaigns to increase public understanding of AI's real limits and its genuine potentials, helping to dispel pervasive myths, reduce unrealistic expectations, and alleviate undue fear. People need to understand that while AI is incredibly powerful, it's not magic, it's not omniscient, and it's certainly not human. And finally, media literacy is more important than ever, equipping everyone with critical tools for evaluating content generated or mediated by AI.
Especially with deepfakes and such.
Exactly. In an age of increasingly sophisticated deepfakes, AI-generated news, persuasive chatbots, understanding how to discern credible information, identify bias, and question sources is a fundamental skill for navigating the digital landscape. All these efforts aim to build a digitally literate, adaptable, and critically thinking society ready to responsibly integrate AI into daily life.
So given everything we've unpacked today, from the humbling Claudius failure to the broader challenges of control, bias, governance, what might a truly balanced supervision model for AI actually look like?
Yeah. What are the practical steps?
Well, our source outlines some concrete proposals that suggest a crucial shift, moving us from reactive problem solving, fixing things after they break, to proactive, structured governance and design. First, mandatory algorithmic audits.
Okay.
This means independent, periodic checks for all high-impact AI systems, those used in finance, healthcare, law enforcement, critical infrastructure, with their results made publicly accessible. And this isn't just about checking for bugs, it's about rigorously auditing for fairness, potential biases, unintended consequences, and adherence to stated ethical principles. Second, we need a system of graduated safety certification. Imagine a certification system for AI, much like we have for aircraft or medical devices, where requirements are proportional to the potential risk of the AI system.
Risk-based approach.
Exactly. A simple chatbot would have minimal requirements, while an autonomous surgical robot or a system managing a power grid would need the highest level of rigorous certification, undergoing extensive testing and verification. Third, we desperately need clear responsibility mechanisms. This means a regulatory framework that unequivocally defines legal responsibilities in case of damages or failures. If an AI causes harm, who is legally liable? Is it the developer, the deployer, the data provider, a combination? This needs to be crystal clear to hold developers and deployers genuinely accountable and provide recourse for those harmed. And finally, we need to establish multidisciplinary ethical committees. These would be standing oversight groups comprising not only technical experts and engineers, but also ethicists, sociologists, legal scholars, public representatives, even artists. Their vital role would be to collectively consider the broader societal implications of AI development and deployment, ensuring that human values, societal well-being, long-term consequences are at the absolute forefront of decision-making. What's truly fascinating about these proposals is the fundamental shift they represent. From simply trying to patch AI when it breaks, to proactively building a robust, comprehensive framework that ensures its safe, ethical, and responsible development from the ground up. It's a significant change in perspective, moving towards foresight rather than hindsight.
And that user experience piece is huge too. The Claudius failure dramatically highlighted the gaping chasm between marketing hype and real-world reality. Users were sold on completely autonomous systems, promising seamless, effortless interaction, often with catchy slogans about future efficiency.
The marketing spin.
Right. But they quickly ran headfirst into the very real capabilities and, maybe more importantly, the significant limitations of current AI. Imagine expecting a perfectly functioning, always available vending machine, only to find it constantly jammed, misinterpreting your order, refusing service for no clear reason, or just displaying a cryptic error message. This creates a massive, frustrating user experience gap between the glossy brochure and the infuriating reality on the ground. Post-incident surveys conducted after the Claudius experiment revealed something incredibly telling. The vast majority of users, perhaps surprisingly to some, actually prefer hybrid systems. Yeah, they explicitly want the option for human escalation when problems arise. They don't necessarily want a perfectly autonomous machine that can't be reasoned with that simply says no without explanation. Instead, they desire the convenience of automation combined with the reassuring knowledge that a human can step in to fix, explain, or empathize when things go wrong, or when the system encounters something it hasn't been programmed for. That small moment of human connection to solve a problem, offer a refund, or just explain why something isn't working proved to be invaluable for customer satisfaction. It's clear people still value that human touch, especially when things get complicated or don't fit the program script.
And if we connect this to the bigger picture of economic realities, the promised, say, 75% reduction in operational costs, often touted by developers pushing for fully autonomous AI, frequently hides a very different, more complex story. These initial projections often vastly overestimate the savings and severely underestimate the hidden complexities and ongoing
The
costs.
hidden costs, yeah.
Exactly. Analysis after Claudius revealed that a striking 35% of automation projects consistently underestimate the true costs of human supervision and intervention that are still required, even in supposedly fully autonomous systems. These are the often overlooked costs of fixing what the AI can't, of handling the exceptions, of managing user frustration, and of the inevitable human backstage labor that keeps the autonomous system running. And it gets even more sobering. A striking 60% of what were considered fully automated systems experience significant service interruptions or outright failures in their first year of operation.
60%, wow.
60%. These interruptions translate directly into lost revenue, frustrated customers, damage to brand reputation, and often more costs to repair than anticipated. So, while the initial promise of radical cost reduction through full autonomy is incredibly alluring, the practical economic analysis suggests that hybrid automation, a thoughtful integration of AI with strategic human supervision, currently offers the best, most realistic cost-benefit ratio. It means leveraging AI for its strengths, like rapid data processing and automating repetitive tasks, but retaining humans for the complex problem solving, the ethical judgment, and the nuanced customer service. This raises a crucial question that businesses and policymakers must confront. Is the unrelenting drive for full autonomy more about theoretical perfection or a perceived technological ideal rather than practical, real-world efficiency and actual sustainable economic viability?
And this is where things get truly surprisingly interesting. Paradoxically, what we often consider human limits or imperfections can actually prove to be invaluable assets in an increasingly algorithmic world.
The upside of flaws.
Kind of. Think about our slowness in decision-making. While AI can make choices in milliseconds, our human slowness allows for critical ethical reflection, for considering complex consequences, and for weighing nuanced moral dilemmas that algorithms can't truly process. We don't just process data, we ponder values. Then there's intuition. It's that gut feeling, right? That sense of what's right or wrong that comes from a lifetime of embodied experiences and pattern recognition that simply can't be formalized or programmed into an algorithm. AI relies on explicit, structured data. We often operate on implicit understanding, on hunches. Our cognitive flexibility is another superpower, the remarkable ability to adapt instantly and creatively when facing the unexpected, when the rules change, or when there's no pre-programmed solution. Claudius simply froze. A human would pivot, find a workaround, maybe even invent a new solution on the spot. Furthermore, we possess the unique capacity to recognize what's important beyond what's merely urgent. AI might prioritize immediate, measurable tasks based on its programming, but humans can step back and see the bigger picture, identifying true priorities, long-term consequences, and non-quantifiable values that might not be immediately obvious.
Seeing the forest for the trees.
Exactly. And of course, empathy is a crucial form of social intelligence. Our ability to connect, to understand suffering, to offer comfort, show compassion, is something that machines simply cannot replicate. It's a critical component of nearly all human interactions, from complex caregiving to something as simple as solving a vending machine dispute with a frustrated customer. These imperfections are not weaknesses. They are our unique strengths, our irreplaceable assets in a world increasingly shaped by AI.
Well said. And the Claudius case has significantly accelerated and enriched the debate on redefining the relationship between humans and AI. It's moved us beyond the simplistic notion of competition or replacement towards a more sophisticated understanding of complementarity.
A partnership, almost.
Exactly. This emergent social pact, this new way forward, requires several crucial elements. First, clarity on the respective roles of humans and machines. We need to definitively define where AI truly excels and where human capabilities, those unique imperfections you just highlighted, are not just indispensable but absolutely essential. This avoids the trap of trying to automate everything, everywhere. Second, it demands the valorization of the distinctive capabilities of both. We need to celebrate AI's unparalleled speed, its immense data processing power, its capacity for automation, right alongside human creativity, our deep empathy, our unique contextual judgment. It's not about which is better, but how they are different and how they can be combined for optimal outcomes. Third, we must diligently develop effective coordination and collaboration mechanisms, designing systems where humans and AI work seamlessly together, amplifying each other's strengths rather than one trying to dominate or negate the other. Think of AI as an incredibly powerful co-pilot, not the sole pilot.
I like that analogy.
And finally, this new pact fundamentally requires an equitable distribution of automation's benefits. We must ensure that the immense efficiencies and the wealth generated by AI contribute to broader societal well-being, enhancing human lives and opportunities, rather than exacerbating inequalities or displacing entire workforces without a plan.
What truly stand out to you about this vision of a shared future where our relationship with AI is one of thoughtful collaboration and mutual enhancement?
That's a powerful vision. So what does this all ultimately mean for the dilemma of who controlled whom? It seems pretty clear from the lessons of Claudius and the broader landscape of AI development that it's not an either question. It's not a zero-sum game where one side inevitably triumphs.
No, it's more nuanced, much more. The true nuanced challenge is building a dynamic system of coevolution and reciprocal control, where humans and AI develop together, constantly adapting to each other's strengths and limitations. The lessons from Claudius are undeniably clear. Complete, unsupervised autonomy, even for a seemingly simple vending machine, is still a premature and often precarious goal. It vividly revealed the fragility of AI when confronted with the unpredictable nuances of the real world and the messy complexity of human behavior. Instead, what the evidence overwhelmingly suggests is that robust, intelligent human-machine integration offers far greater resilience, adaptability, and ultimately success. The way forward, then, seems to be strategically developing systems that amplify human capabilities, systems that make us smarter, more efficient, more capable, rather than attempting to replace us entirely. And this means always keeping the ultimate responsibility, the final ethical judgment, and the ultimate accountability firmly in human hands.
Human agency is key.
Absolutely. The future isn't about AI operating in isolation or human intelligence struggling alone. It's about forging new forms of collaborative intelligence, where we truly value and leverage the distinctive strengths of both, learning to share the driver's seat with wisdom and foresight. So maybe the question for you listening is, what will you explore next as you continue your own deep dive into this evolving and profoundly fascinating relationship between humanity and its most powerful creation?